or do you think that someone else wants to join?
I'm just oh blimey, my just give me a second. My
Mhm.
video isn't working for some reason. Turn on camera. I'll sort that out in a second. I'm just going to message here. Anyone wants to join? And so there you go. Send, that'll do. Right, let's get that in there. This is really annoying. I tested all my camera and now it's not bloody working. Typical. That's because I have it on there, not on there. Okay. Never mind, I'm going to turn my camera off now. Right, well, first disappointment aside that I can't put my camera on there. Let's see. So yes, I got set up. That's
Okay.
all good. I'm streaming this, by the way, so I can come back to it later. If
Okay.
unless you're object at all, I'll turn it off. I can just turn it into private recording.
I
Ah,
must admit, hi. I must admit that I was a little bit surprised that our last session shows up on YouTube um, publicly, because I felt that I said maybe
I
one or the other thing that was maybe a little bit, yeah,
ah, nobody says
not.
anything.
I'm not sure that I that it was ready for everybody to listen to forever. um,
I think it was fine. Right, let me turn this. Hey Tom. Hey, how you doing? Right. Good, good, good. Let me just, can I disable that? I'm going to remove that. Yes. Close. Start a virtual camera. And then I'm going to see whether or not this thing will accept my virtual camera instead. Bit of teething. I thought I would OBS virtual. There we go. Look at that. There I am. It's really weird. I've had to virtualize it through OBS because OBS is grabbing my camera and won't let Discord use it. So okay, OBS, pretend to be my video recorder then, my webcam, right? I would prefer to get away as close to past as possible. We can do this initial one. Half an hour, I'm hoping, is plenty to start off with, and then we can because I've got to go next door. We've got a meeting, a residents meeting, so I'm going to meet up with those guys. So I can be a few minutes late, but that's fine.
about something, you are likely too polite to say you are bored. So better the other way around. Okay, this is about this Raspberry Pi Pico, the RP2040.
Yeah, synchronizing.
After working several, let's say, iterations, I have now come up with creating. You're still there?
Yeah, I'm still here. Sorry, just.
And the individual firmware projects can make use of this reusable library. And maybe we can take a very quick look into the library thing.
Yeah.
I share my screen. I hope this works. Share.
Yep, and then I can go into that.
Does it already work? Can you see something? Or because I feel that it does not work.
Usually what you do is share the main screen that you want, and then it'll come up as an extra on here, and I can click into it. Like at the bottom, share your screen, pick the one that you want, and then it will say,
Okay.
Oliver is sharing.
Okay, I will try to figure this out. So with entire screen, it for some reason doesn't work. I think the share button is always grayed out. I think it does not work. I think I have something not set up correct. No, I did it wrong. I try again. Okay.
There you go, you're live.
Okay, great, cool.
And then I can.
Okay, so we have this project, A2Pico, is it called?
Yep.
And there you have these parts here, and you in the top folder you have the source code that makes up this reusable library, and then there's a demo subfolder with a simple firmware that makes use of this. And in this top folder you have this file that is with the extension PU, and that is the source code of the PU state machines that are used here. This is even a little bit documented and has comments if you want to look at it.
Yeah, I've been reading through a lot of this.
Oh, you have already looked at it? Okay.
Oh, yeah.
Okay, yeah, maybe you're. And then you have some C code, which is primarily about initialization of this whole thing. And you have the header file that exposes the API. The API is basically about initialization. Then you can optionally have a reset handler. And then you have the, let's say, the core things, which is get address, get data, and put data. The idea is that you always call get address to get the address that the 6502 is working on. And by the address, you also get the information if it's a read or write cycle. And if it's a read cycle, you at some point need to call this put data to answer basically the read request from the 6502.
Yep.
And if it's a 6502 write cycle, you can at some point get the data that the 6502 is writing.
Okay.
So it's already, let's say, somewhat abstracted. And and then you have this template that I created for you.
Yeah.
And maybe you. Sorry if I say things that you all know.
No. Assume I know nothing. It fills in the blanks. If I start telling you things, you make assumptions about what I know, and then I might miss something. So.
Okay. So the question: how is the reusable library integrated into this firmware project? There are, of course, several options. You can just copy it in. You could use a Git submodule or whatever. I like to use this CMake fetch content thing. basically, I put just this here, and then I say that the A2Pico is one of the dependent, one of the target libraries I'm depending on, and basically that's all I'm having to do, and then this library is just there.
A quick question on that: would that then recognize changes immediately if I came back to a project and then?
Sorry, okay, can you please repeat? I didn't get this.
If I come back to a project that I've been working on and there's been some changes to that GitHub repository, do I just run CMake and it'll automatically pull them down?
So you mean this this library?
Yeah, just if you change
This
A2Pico.
this library is pulled in once when you call CMake, and at least maybe it can be done in a more clever way. But every time I want to refresh this, I usually completely
clean. Just do a
remove the
clean.
data. I clean up, I completely clean the build folder and just run CMake again.
Okay.
And then I have a fresh copy. Yeah, maybe there are more sophisticated ways to do it, but is the way I do it.
No, that's fine. That's fine.
And okay, the other maybe somewhat interesting thing is that with these two statements here, I'm redirecting the standard I/O of the Pico away from the UART towards the USB port. So this is basically all that is necessary to get the standard I/O functions of the Pico C library to work on USB instead of some serial port.
Cool.
Okay, the rest is more or less, yeah. Something here. Building the firmware using CC65 is integrated here, and it's made here with a dependency. So if you really change some source code and then run make, it will really rebuild everything that is necessary.
Cool. It's nice and clean. I really like this.
Yeah, thank you. I'm not good in these things, so this took me quite some time. I must admit, I had quite some learning curve to get this done here, but I wanted to have it in a way that I feel is good enough for others to reuse and not just a mess. Okay, then let's maybe start.
So I had a look at the firmware. That is very, very recognizable.
Okay. Yeah, I hoped that at this point for you there is basically not really much that is hard to understand, but I think there are maybe some things nevertheless. So interesting to point out. The first thing is obviously I'm still trying to have most logic on the Pico side, and as little logic as possible on the 6502 side. However, in contrast to the Applewin emulator, you have, of course, from the Pico, no access to the main memory of the Apple II. So the one who moves the data back and forth between the two memories needs to be the 6502, because that's the only piece that has access to both. So what this here does is pretty much, I think, what you would expect it to do, which is it basically, here it starts, it picks up the parameters that are into these 40 something zero-page variables. It picks up those values and writes them into some virtual port. And then depending on what was the command, for example, if it's of course a write command, I need to write the actual block. If it's a read command, I'm basically done with just the parameters. So it's here about checking what was the command. Was it a status command, read command, write command? And for example, for the read command, I'm already done when I have written these general parameters. Then I go into this subroutine here, the return code thingy. And this basically writes a single value into a status port and then loops to read on the status port. Basically, this writing is the trigger that the command should be carried out. And this read loop is waiting for the result to have been completed. And then it reads from the data port, where before it was only writing to here. Now it reads from the data port to get information. For read, it's primarily for read. Let me see it. It's here for a read. It's reading first the return code, and then it's actually reading the block. And these read and write block here things must I say, I'm a little bit, let's say, not proud of, but I think you can, I believe you cannot do this much better.
I read that, and it's a really good way of reading to 512 bytes. Just out the thing in front of you, and then ink the buffer one. I thought, wow,
Yeah, and the
that's
idea to use this first as subroutine and then falling into it, so that the return here one time for the waiting for the second block and then returning from the whole thing. I think it's pretty, yeah, let's say elegant this way. Okay, now for the technical stuff. This piece of code is repeated 8 times for the 8 different slots.
okay. Yeah.
And every time this slot variable has a different value.
Yeah.
So when it comes to accessing the I/O ports, which are slot dependent, then there is no indexed reading or indexed writing. Rather, I'm let's say generating the right address, the fixed address for every slot.
Yeah.
This is something that with your Apple Win, you do this by patching the firmware.
Yes.
Dynamically. Here, I'm doing it by generating the firmware 8 times with these different parameters. And this is basically, let's say, important because this means the benefits are important. This means I don't have to have indexed access, so I don't waste a register. Without the indexed access, the access is faster. And additionally, something, maybe it's not maybe not obvious at first sight, but for example here, I'm doing a jump subroutine in something here. If you would not have the code generated 8 times, you couldn't do that because the address, of course, is every time another address.
Yeah.
So jump subroutine and jump becomes only feasible because you generate the code for individual slot independently.
Indeed, and that's exactly the issue I faced with when I put in the ProDOS handler into the Apple Win. That was yet another value I had to overwrite, depending on the the slot it was being loaded into. The first, I completely forgot the first time, and I was wondering why it was jumping to a completely wrong address.
Yeah.
Like,
okay, then you already know this basically where these problems are.
Yes, exactly.
Okay, great. And then the other thing, I'm not 100% sure how much you know about it. Then you have this shared ROM space starting with C8. You have maybe when it came to the discussion about flashing the soft SP, you had this graphic with these 7 sections with one hex 100 byte, and then there was a big section with the 800 bytes below, maybe here. And here you have these 800 bytes. Point is, it's a lot larger. I have prepared this for you because I'm pretty sure, or basically I'm absolutely sure, that you're not able to put a whole SmartPort handler into the 265 bytes of slot memory. The code you need is, I believe, too complex to fit in there. So I'm pretty sure that you will need this additional space, and therefore I already prepared this for you. And additionally, I already put some code from the slot ROM into this, what is usually called expansion ROM. First to show you how is it used, and basically also to give you as much space in the slot ROM as possible. Okay, why that? Point is, you have different attributes in these two areas. The positive thing about this slot ROM is that you have it individually for each slot. That means when it comes to actually accessing the ports, then you can have there the hard-coded address. if you want to read or write from one of the I/O ports from within this C8 area, then you're back to the problem of having to use an indexed read or indexed write, because here this code is shared for all slots. On the other hand, you have here more space, and you have, yeah, basically that's it. So, and that's, for example, the reason when you now look, why have I structured this way? I try to move as much as possible from the boot code, move that into this C8 area, right?
Yeah.
So I do a jump subroutine of some preparation, which is here. It's basically setting up the parameters for reading block 0 to 800 from drive 1. And then I go back in this place and jump subroutine driver, which is actually doing I/O. And then I say jump now to continue. And then I check, did it work? And the usual thing. Was it okay? If yes, I jump to 801. If not, I check if I want to continue the boot scan or try with an error and end up in basic.
Yeah.
So why did I structure it this way? Yeah, because the driver code is the one that actually accesses the I/O addresses. Therefore, the driver, the low-level driver, put it that way, wants to sit in the slot ROM. Okay, but why did I then just have a big subroutine in this C8 ROM that does everything? Yeah, because I cannot have a jump subroutine from this C8 stuff that jump subroutines in some slot area, because the slot is at different places.
Yeah, we don't
and
know
this
which
code
one.
is shared. So where should I jump subroutine to? Yeah. So
To the
you see,
static.
you have pretty strict restrictions in how you can structure this whole thing.
Okay.
There are, of course, tricks how you can jump from this code area to the slot area, but it's not nice, complicated, and yeah. So, but you already get the point. So it's not very easy to structure the code, and yeah, a lot of limitations what you can do. And then finally, the last thing that maybe it's not clear right now to you is these two lines. I would like to explain quickly to you. This code, this area here, this expansion ROM is shared. And there are certain, let's say, ways how it is used. This is not technically enforced. Rather, all code making use of this needs to follow these guidelines. And technically, it's working like this. As soon as you access your slot ROM, your expansion ROM is activated. And then you can jump in there. But when you go away from your expansion ROM, it's not automatically disabled. And there's no code to, let's say, disable it on exit. This is not how it's supposed to work. Rather, your expansion ROM stays enabled. Yeah, but what then happens if someone else wants to enable his expansion ROM? You cannot have two enabled, because if that happens, you really have a bus fight. You're basically shortcutting your output drivers. This can really cause hardware damage. It's not fun. And therefore, the logic that Steve Wozniak came up with is that there is a certain address. This is CFFF. It's the last byte of this shared space. If that is accessed either via read or write, then everybody must turn off its expansion ROM, and all are off. And then you just basically by fetching the next code byte, you are activating your own one again. This must not be done by a fetch, but usually it's done this way. So by putting this code here, this line disables all expansion ROMs, and by just fetching this LDX, you are again activating your own expansion ROM. And by this time, only one is active, and therefore it's now safe to jump somewhere there.
Right.
because as long as severals are active but not used, it doesn't hurt. It only becomes really a problem if the CPU tries to read data from one of the addresses. And therefore, you do these things, and then I can have this jump subroutine here that really gets into this space. Okay.
Cool. Yeah.
So yeah. And then the final thing is this, let me see, it was this line here, this store. This is because of interrupts. The problem, at least with, especially with the Apple II, the old series, the Plus series before the enhanced Apple IIe, these machines have soft switches for doing several things with memory banking, but you can only write basically the things. You cannot read back how is the current setting.
Yeah.
Is my language card banked in? Is bank 2 or 1 banked in? I'm currently in high res, low res, or text, or page 2, or whatever. You can only change those things, but you can never read what is the current status. It's completely missing. The same with which expansion ROM is active. Nobody knows. The machine cannot know. But the problem is, imagine you are just executing code sitting in your expansion ROM, and now there's an interrupt. Then the interrupt handler comes, and the interrupt handler, you think about a mouse, the interrupt handler then jumps into its firmware. And that firmware might, well, not unlikely, need an expansion ROM. So the interrupt handler disables all other expansion ROMs, enables its own expansion ROM, does it, and then at some point returns from the interrupt. And if you do nothing, yeah, you jump back to that code in C8 somewhere, but yeah, there's no ROM anymore there, or the ROM from the mouse firmware is still there. Yes, it's done, over. And therefore, there's an interrupt infrastructure on the machine, and the actual interrupt handler does not really end with a return from interrupt, but it returns to, let's say, the infrastructure, the framework, the interrupt framework.
Mhm.
And that interrupt framework looks at this address here, M slot, and just touches the memory, the slot memory given here. So it activates again the expansion ROM that was active before the interrupt.
Right. So an interrupt happens at the end of it. It knows to LDA the expansion ROM associated with M slot, and that activates your own expansion.
Yeah, of
ROM.
course, after doing this clear thing.
Yes.
So it basically does a bit or whatever with CFFF, and then it does some LDA or whatever with this address given from the high byte from the given of 7F8.
Okay.
That's basically what's in that interrupt infrastructure code. Therefore, you need to set it before you activate your ROM because of potential interrupts of the machine. Yeah, all this needs to be known, right? And if you don't know it, it's your fault.
Yeah.
Okay, and this is a part of let's say knowledge that you just get when you use this code.
Yes, I'd come across MSlot before. I definitely hadn't seen the nuance of the CFFF and various other things, so that's really interesting. Because I think the firmware for the Apple one uses MSlot. Something does because I had to read it.
Yeah, here it's used for another purpose because it's basically, it was originally used for something else. That interrupt thing came later.
Yeah.
Originally, it was primarily used by the slot scan, and you here use it to check if you think that a slot scan is currently happening or not. But it's basically only guessing. There's no clear. The whole idea of continuing a slot scan was not really designed into it. It was an afterthought.
Okay.
Therefore, this guessing here, there's no clear API for this. Okay, can we continue a little bit? Or
yeah, absolutely. Carry on. There's no worries on that. It'll start late.
Okay, so we have the firmware, and then you have this board thing, and you saw that the firmware was using C088 and C089, right? And this corresponds to these lines. Okay, this is exactly what it corresponds to. At 8, you have the data port, and at 9, you have the status port. The data port, you can both read and write. above is the read code, below is the write code.
Yeah.
And the thing is that it is an auto-incrementing pointer. This is always the best thing to do. People often don't see this at first sight and think, you might want to put, let's say, a shared RAM area or whatever, but this is really not great because the 6502 then needs to use indexed addressing and whatever, which makes it only more complex and slower. When you already know that you are going to read or write this data in a sequential fashion, an auto-incrementing pointer is always the fastest and best thing. And you basically see here that I'm implementing an auto-incrementing pointer. You can read from it, and then the read offset is incremented, or you can write to it, and the write offset is incremented. And then when you are done, you're basically writing to the status when everything is, let's say, activated, or you're reading from the status to see if things are done. Very simple. And this read and write pointer and this buffer is all declared, let me see, it is all declared here. And it's all a global volatile variables. This is all, of course, not very elegant, and it's certainly not C++ style-like, but it's what works and is fast.
No, there's no worries.
Sorry?
There's no worries. That makes sense.
Yeah. So yeah, because this way I'm just basically sharing this buffer between the two ARM cores. One ARM core that sits close to the Apple II can read and write to this buffer, and the rest of the Raspberry Pi can read and write to this buffer, and the status tells everybody where are we, who is just writing, who is reading, who is done, when we are, what is the current status of this, let's say, back and forth transfer. And there you can see in this code that is called SP for SmartPort already. Also, nothing with SmartPort happens here. Right now, it's only a pure old-fashioned PODOS code, nothing with SmartPort. You can see it says if the status is 1, which corresponds exactly to what we wrote in from the 6502 code. Then we are starting to work on it. And when we're done, we are setting the status to 80, which then makes exactly the loop return that we saw before.
Okay.
So you have the handshake here. This one is set by 6502, and this 80 is checked by 6502.
That
And in
makes
between,
sense. Yeah.
and in between, you have this code, and this code is running on the other ARM core, which is not real time. It can take as long as it wants, because here the Apple II is waiting. You can take your time. It's
Right.
not real time anymore, right? And
That I was going to ask earlier about how we synchronize that, but that makes complete sense now because you've got that loop in the 6502, and it doesn't matter how many times it
yeah,
goes
that's always a
around.
very interesting point. Where do I write code where I need to be ready by the next 6502 cycle, basically, because it's just sitting and waiting. For example, very important is you have seen these codes where I read a block or write a block. Inside these loops, I never touch any status. I'm just saying, okay, I can continuously write 512 bytes here, or I can read these bytes. And already know that there's room for them or that they are there. That's the thing, and that makes it fast compared to some serial or whatever process or protocol. Yeah? Because I'm working on the whole buffer as synchronization mechanism and not on individual bytes. This makes it, let's say, fast and efficient. And
One quick question. So it's working on 512k blocks, is it? 512 bytes blocks, are you saying there?
basically, you see the buffer is already 1 kilobyte.
Yeah.
Because I know that for SmartPort, you sometimes need some 700 or whatever size.
Yeah.
So right now, because right now it's only, I forgot to say this. What you have here is maybe in some areas more than you would have expected from me, but in other areas, it's certainly less what you have expected from me. It's certainly, for example, it had nothing to do with SmartPort so far. You see, it's just a plain old PODOS block driver.
Yeah.
Everything having to do with the additional SmartPort entry point and all the code that is necessary is totally missing. Yeah, it's It's so far it's only basically it's just the part that you're least interested in. But yeah, that's what
But
there.
it's the framework, and then with the
And
SmartPort
I think
code.
and the great thing is I think that by now, by the work you've done so far, you have a clear understanding of the relationship of the SmartPort entry point, the Protos entry point, and the boot entry point.
Yeah.
By having what you have done so far, you clearly understand the relationship between those three, and therefore you can see clearly what you already have and what is missing. And
You,
that's the good thing, I think, about it.
you've been a good
Okay,
teacher, yes.
thank you. Okay, and this here calls into sleep status, sleep read, and sleep write. And right now, there's basically nothing in there. They are empty. They are just printing something on the USB port. And here comes where you would then implement the sleep protocol and whatever is above on this to really make appear to the Fujinet. And my proposal would be, at least if I were you, I would approach this way. I would maybe start to now implement something that really talks to the Fujinet PC in the right way and add code to Fujinet PC that accesses a serial port on the PC, talking to this and make this work. I think you might like to see something really work. And it should be possible to have access to the first two disk images sitting on the Fujinet and accessing them via this code.
Yeah,
Um,
that seems very. That's a really good first step, because then what we can do is effectively we've got. Thank you. We've got Fujinet PC running, a virtual version of Fujinet with a USB cable from the PC into the Apple,
exactly.
acting as the Fujinet, and it really running against 6502 code. So yes.
And I think maybe it's not the most important step, but I imagine that you would want to see that work because that's a nice, let's say, self-efficiency, whatever experience. And I guess, and on the I presume that you already know on the Fujinet side there is already code for accessing the serial port both on Linux and Windows because this is used for the Atari CO access. So there should already be code that you can just reuse as is.
Okay. Good.
And if you got this working, then my next step, at least my next step, would be to emulate this hardware in Applewin.
Oh,
It means the idea of having two ports and this buffer where it can just write and read into this buffer and write and get data back from the buffer. Because then this firmware here should work in Applewin as is, completely as is. And then you can continue to improve this firmware to do really SmartPort all inside the Applewin environment. You can have very quick turnaround times, can debug and whatever. At least that's what I would do. You see?
I hadn't thought
Basically,
of that. That's very interesting. So
moving right now, your emulation in Applewin is really basically just fake because you are
yeah,
doing it
yeah, all in the
totally
C++
inside
code.
Applewin.
Absolutely.
And you can maybe move this emulation to be a little bit more realistic by doing these things this firmware does. Really transporting the data back and forth via the, let's say, in Applewin emulated 6502. Because if you have this emulation, then you can start to create the additional SmartPort code completely in Applewin and test it in Applewin, because then you can leverage the idea that having the same data over TCP/IP and USB is the same from the perspective of Fujinet.
Yeah.
And then when you have this firmware extended to do SmartPort, you can just port it back to the Pico on the real Apple and it's supposed to work.
It's mind blowing how many levels of emulation there are, and then
Yeah,
we've got a Pico that's interacting, and then we're going to backport that to Applewin on the PC, and then we're going to extend that, and then we're going to put that onto a card, plug it into it. Oh my goodness!
So, but you see the point where you can now leverage the idea that you have the same thing on Applewin than on the real Apple,
Yes.
because you can move your firmware back and forth, and it's supposed then to work in both ways the same. So you can really develop the firmware virtually on the Applewin and then move it.
And this is
to
great.
the
I've got a couple of months. I've got a couple of months of developing this, and then when I get to the VCF East, because my talk is going to be very much about what I did with Applewin and that type of thing, and I think it will basically naturally extend into this.
And that's what I said before. You could, of course, start with doing that. Right now, start just with Applewin and do nothing with your Pico you have. But I think you wouldn't like that. I think you would much more like to now really implement the S-Slip protocol and really see the Fujinet PC working against a real Apple, so that you see how this will at the end really work.
Well,
You continue to work on
yeah,
it.
exactly, and that's where you can start stripping away the virtual layers and start introducing more hardware and hardware
Mhm.
and hardware, and say, look, here we had it working virtually. Oh, I can just plug this in. So that's all completely in Applewin. All right, how about I plug this into a PC and I'm running the Fujinet there? And yes, and then we get that layer, and then we move into real hardware, and then we can show, and it still all works across here. This is great.
Yeah, and then at the end, the last step basically here would be just to complete the picture, that we move Fujinet from the ESP32 to the ESP32 S3, which has native USB support. And then you can move
Yes.
Fujinet PC to that new ESP board, and then just plug it to the USB port from the A2Pico, and then basically you are done. This is, from my perspective, the final goal.
Yeah. Wow. It's like stepping stones all the way up to the top.
It's a long way. When you think about it, I had this already completely in my mind when I jumped into the Fujinet community, where it was still running on the ESP IDF 3 point something, totally not supported by the ESP32 S3. So I did this very large commit to bring the whole project to the current ESP IDF, because only there we can ever get forward to the S3, which is only supported by more recent ESP IDF
Yeah.
versions. So it was really like a long way, and or it's still a long way, but I think most steps, would say at least much more than half of the steps are done right now. And what I want to express is that this is only possible because of your engagement and your initiative in all this, because otherwise this would not be.
Well, I wouldn't have started this without. Actually, I think it was just seeing a screenshot of Applewin at some point from you, and I went off to have a look. Right, I need to write network library for this machine that I've never seen or used. All right, how good's the emulation on it? I was expecting something like Altera, and Applewin was the closest thing I found. And then I thought, who is it, Tom, who does 5CS, who wrote the first bit for his own testing for JSON? Or am I getting two people mixed up? So he wrote
Eric. Yeah, Eric Carr.
That was it. And Eric wrote some stuff, and basically said, "Oh yeah, you can do this type of thing." And obviously, it was very, very basic, but enough to kind of pique my interest in then writing something myself. And then, yeah, as we said before, it's just turnaround is really quite quick on these type of things. So no, you've inspired me. I have been massive. I feel like I've been pulled massively into the Apple side, but I don't mind. I'm really enjoying it.
It really depends on you how much you want to do this, because if you are interested, and you can of course go even more, because what we are talking about here is basically a subset of what I want to finally do or have with this A2 RetroNet firmware. Because the A2 RetroNet firmware is supposed to combine this type of SmartPort controller that we're currently talking about with an emulation of, let's say, 1.5 super serial cards.
Right.
all in one slot. And I have this already working as a prototype, and this is what I demoed last year on Kansas Fest.
Kansas Fest, yeah. I did watch
And
that.
it was just a hack. And I've moved forward in different ways, and therefore I'm pretty far away from the functionality I already had back then. But if you are interested and really willing to invest, I would really invite you, if you want to participate in this A2 Retronet firmware creation project. So if you are interested.
It's all
I
fun.
just
It's all getting there. Tom, your
I don't know.
microphone went off.
What I wanted to say is that if you are interested in contributing or working or participating on this A2 Retronet firmware, where I showed the prototype last year, then I would be very welcome.
And I think I shall probably, when we get there, be very interested in that. Absolutely.
Nice. Yeah, I just wanted to tell you that it must not end with this if you are really into it.
Yeah.
And I'm mentioning this. Sorry, we always write all the time, but just this sentence. I'm mentioning this for one special reason. If you look at this project right now, you might think, "Oh, I should do this in a little bit different way. I should do that in a little bit different way." And for this project, it might make sense. But if you then try to put this into the larger context with this A2 Retronet, then you have additional limitations and additional, let's say, side effects. So maybe it would be good if you are not investing too much time into redesigning what we currently have until you have maybe seen the full final picture of how this is supposed to fit together. And then you can see where you say, this is really just, let's say, old school C stuff that I can do much better in nice C++. And I'm not against that, but I think it would be good if you only do this if you see the full picture, what also wants to be in there, and what are the relationships and the restrictions and limitations and whatever.
Okay.
One final thing, I started last year with a SmartPort handler for this type of firmware, and I need to quickly find it, and I will send it to you. It's very far from being complete, and it's pretty likely buggy, but maybe it's some inspiration to you how I would imagine to think about this, because it's really not easy. This simple Protos handler, for example, needs no temporary variables. It can use just the variables on the 0 page that are already there. But a SmartPort handler is in general not supposed to use those 0 page locations. You might use them anyway, because you see whoever calls this handler and calls that handler must not using those variables on his own, so they are likely free. But nevertheless, you might think, I'm not doing this. And then it gets hard. Where do I get some RAM from that I can use? And so it's not easy. And maybe we talk more about this in a written fashion, or have another call or whatever, because I think you said you need to go now.
No, absolutely. They've started behind me. That's fine. Tom, your microphone keeps coming in and out. Would you like to say something?
I just want to end by saying that I am really seriously enjoying the cross-pollination that's happening here.
Yeah. It's excellent. I'm loving it. Yes. Absolutely. I'm not going to be able to develop this all in one go anyway. So what we'll do is we'll review as I go along. I'll add little bits. I like the way that we can start this, then move it across to Applewin, and you can start reviewing it. And I definitely want to have more of these face-to-face times. I might just record them locally rather than streaming them, because it screws around with my entire OBS setup, but never mind. But apart from that, this is a really, really good intro. Thank you very much. And as Tom says, it's really exciting, and it's a really good cross pollination between things that we've been looking at.
The point, maybe I should emphasize this. The thing is that I have more or less all this already in my mind, basically since years.
Yeah.
But I'm unfortunately far from able to realize this. I have just not enough time, and sometimes, at least sometimes, I also just not have enough energy. And you seem to be willing to invest a lot of time and energy. And as long as you have fun with doing that, I'm more than happy to provide you and give you input with all ideas and knowledge and whatever I have. And I'm more than happy to see that some of these things get realized better, faster, and whatever than I would ever be able to do it on my own with my limited resources.
No worries at all. Thank you very much, and thank you for having the plan to do all this and us to be able to build it. So this is great. Right.
Yeah.
Okay.
So
Thank you very much, both. I will. I'll put the stream there.
Okay. And yeah, to me it's nice, and we could have this more often. And I think we are much faster and more efficient than always just writing back and forth.
Agreed. Always. I mean, when at work we do exactly the same thing. If the conversation thread goes beyond about 5 or 6 messages, we jump on a call. You know, it becomes too difficult to. People start thinking that you're having bad ideas or that your attitude is wrong, and you know it's very difficult sometimes when you're in a conversation text to express it correctly. So.
And maybe I should say I'm working from home, and
Yeah.
I'm having video calls now and then, but I'm having relatively often no video call, and then I'm also available for a more like a spontaneous conversation.
Okay, cool. Will do. I'll knock you up on that one. Right. Thank you, gents. I'm going to head off
Okay.
and say goodbye.
Then I